meet again in the third week. We are already week 3 during our semester. So today I would like to share about cooling load, or load calculation. Uh, as mentioned in the slide here, yeah. So the cooling load is actually will serve in the room or zone depend on the barrier condition of the space. So before we go to the load calculation, let me introduce first the definition about relate in the cooling load. Yeah. So right now I would like to explain about the space, what differentiate between the room and zone. So we go first the understanding about the space. Yeah? Space indicate either a volume or site with a partition or partitioned room or group of room. So actually a room is an enclosed or partitioned space that is usually treated as a single load. So as we know, maybe the space will be content of the several of zone. So we need to serve condition depend on the zone treatment. So as we know, the space is bigger than compared to the room or the space. So how about the zone is a space or several room or unit space having some or sort of the coincidence load or similar operating characteristic. And a zone may or may not be an enclosed space, or it may consist of the many partitions room, and it could be a conditioned space or space that is not air conditioned. A conditioned zone is always equipped with an individual control system. A control zone is the basic unit of the control. So actually, we can condition the several partition of the room, and we can condition this condition as a zone. So zone actually we can be partitioned by several of the room, and maybe we can condition this as a zone if we want to condition in one condition of treatment. Let's say we want to adjust the temperature in 22 degree Celsius, and then we collect this in several of room or zone, and then we can calculate uh, the cooling load every of the zone conditioner. Yeah, and then in one space maybe several content by several of zone. Yeah. Okay. Now we try to understand about what is the cooling load is like. Where is the cooling load come from? Yeah. So the first maybe can be come from the convective and radiative heat. Yeah. So whether heat enters the conditioned space from the external source or released to the space from an internal source, the instantaneous heat gain of the conditioned space can be classified into two categories, convective heat and radiative heat. So based on the figure, we can figure out what the definition convective and also radiative heat. So as mentioned in the figure, you can see, radiative, radiative it can be from the outside source like the solar. So and then because of the solar can be create heat in the from the windows and maybe from the wall itself can be transferred into the space. And then how about the convective based on the uh, medium. Convective is transfer from the solid material, different with the radiation. Radiative is from the radiation of the solar, so different medium. So the medium from the solar, from the radiation, we call a radiative. But when we talking about the convective is in from the solid material. So as we know, in the solid material can be transferred from the other side to other side. So let's say we try to transfer one stick of the steel. We hit one end of the stick, and then the heat can be transferred in the solid steel. That's we call the convective. And then in the space and equipment load, we can have several parameter to sum, we come to cooling load total. So we have here space heat again, represent the rate at which heat enter conditioned space from the external source or is released to the space from the internal source during a given time interval. So other parameter to calculate the sum of the cooling load can be from the heat gain, and then space cooling load of a symbol called the cooling load, QRC, is the rate at which heat must be removed from the conditioned space so as to maintain a constant temperature and acceptable relative humidity. The sensible cooling load is equal to the sum of the convective heat transfer from the surfaces of the building envelope, furnishing, equipment, appliance, and the equipment. So can be total from there, from the all that can contribute of the heat in the space. And then other parameter is space heating load. Is rate which heat must be added to the conditioned space to maintain a constant temperature and sometimes is specified relative humidity. Then other next parameter is space heat attraction rate. Is rate at which heat is actually removed from the conditioned space by the air system. The sensible heat extraction rate is equal to the sensible cooling load only when the space air temperature remain constant. Then other parameter is coil load. So the rate heat transfer at the coil, the cooling load coil load is the rate at which heat is removed by the chiller water flow through the coil or absorbed by the refrigerant inside the coil. That's the principle of the coil load system. And then the next parameter, the heating coil load, is the rate which heat is added to the conditioned air from the hot water system or electric heating element inside the coil. And then the next is parameter refrigerating load. Is the rate at which heat is absorbed by the refrigerant at the evaporator. For central hydronic system, the refrigerating load is the sum of the coil load plus the chiller water piping heat gain, pump power heat gain, and storage tank heat gain. So for the most water system in commercial building, the water piping and pump power heat gain is only about 5 to 10% of the coil load. So from this parameter, we can be calculate a condition to the treatment in the space. So this parameter we can put inside the plotting in psychometric charts. Maybe later on I would like to explain more about the this parameter into the psychometric chart. So before that, I would like to explain about the condition of cooling load. So as we know, the cooling load will be implemented in daytime, mean that during night the aircon in the office, common commercial office will be shut down the refrigeration work. So as mentioned in the figure, you can see the figure that only in working hour the cooling load will be implemented. Yeah? So let's say the graph mentioned is before 8, mean that the uh, 1 hour before office hour, the refrigeration already starting. Yeah, mean that before the office or staff coming to the office, mean the room already cooling. Yeah, in cooling condition. So mean that the worker or passenger already feel comfort, yeah, before uh, starting their job. Yeah. Space and equipment load, cool down or warm up period. The period come okay. Before that, yeah. As I mentioned before, so before office hour, the warm up period already implement apply in the space. Yeah, this period commences when the air system began to operate and end when the space temperature or other control variable have attained predetermined limit. During summer, the supply of cool and dehumidifier after the air system is turned. Yeah, on causes a sudden drop in space air temperature and relative humidity. Both heat and moisture are transferred from the building envelope to the space air because of the comparatively higher temperature and moisture content of the building envelope. So mean that before and after of uh, office finish, yeah, the aircon already experience in the cooling down. Yeah, so mean that the serving, yeah, will be slow down. Yeah, to shut off, but not suddenly. So the treatment of air will be slowly, yeah, until to finish. So when the finish, yeah, the the refrigeration systems cannot be shut down suddenly. So by cooling down first, yeah. So these are several implement graph, yeah, that can be maybe considered to serve in commercial office, yeah. So in the upper graph is shown the cooling down, yeah, temperature, and then the mean that the temperature is come from the higher, and then by the time, yeah, in the office hour become down. Yeah, you can see the second graph here. So the energy consumption maybe starting is maybe slowly, yeah, here, and then the sorry, this one is cooling and then become a peak by maybe near to the peak in the during from the uh, at the 12, yeah, o'clock until to 4, because the time is uh, sunny, is in peak, yeah, condition. Okay, if refrigeration is used for cooling during the cool down period, this is usually lasts less than 1 hour. Yeah? Depending mainly on the tightness of the building and the difference of the space temperature and humidity ratio between the shutdown and cool down period. So sometimes they give 1 hour before and after. Yeah. So this one is the condition, yeah, when the sometime we implement to winter condition, yeah. So I don't want to explain. So maybe I try to explain more to the how to calculate, yeah, in the cooling load. So actually depend on the material construction. Okay, we have based on the ASHRAE handbook. Actually, the construction material is divided by 3 types. Yeah, with the heavy construction. Yeah, mean that difficult to uh, make cooling load, because sometimes they store the heat inside of the material itself. Sometimes it's very easy, sometimes it's medium, and then sometimes it's very hard to make the cooling down. So sometimes the material is considered heavy. Yeah, we can categorize under 130 pound per feet square. So mean that in the square we need to mass of the construction is higher. So mean that if we have a mass inside of the material, mean that too many molecule inside the in the mass. Yeah, mean that we can store the heat inside of the material. And then what actually can parameter can contribute in the heat. So as mentioned in the slide, we have one parameter that can be from the walls and roof. We can that there can be storage of the heat, because of some material, easy to storage of the heat, then they will keep inside, and then very difficult to gain the to release mean the to reject the heat, and then from the solar, and then from the conductive heat again coming, from the coming maybe come from the device, from the lighting system or electronic system, and so on, and then heat gain turning from the partition wall, and then infiltration of the outdoor air into the conditioned space, and then other internal cooling load, because of the we will supply of the participant inside the space, like people, and then also inside of the we have internal contribution of the heat gain. Okay, this is actually that on to explain the condition when we try to make or serve, in the refrigeration service in to treat the air condition in the space. So as mentioned in the graph, actually we try from began from the O. O is mentioned the outside, outside air. So actually we collect the oxygen, or air, to treat is from the outside space, and then we collect, and then we uh, uh, contain in one chamber we call the mixing chamber, and then we mix within the because why we call mixing, this chamber we will mixing within the return air and outside air, so that's why we call M as a mixture. And then after that we try to transfer this air to the CC. CC mean the condensed air leaving the coil. So mean that the after compressor release the cold temperature from the coil, we call the CC, and then from the CC we transfer from the leaving coil to supply air, let's say in the ducting system, and then we call S, and then S will be supplied to the space, space. So space may be in what we call for what we call in the ceiling, and we try to supply from the roof, and then from there we go to the equipment, yeah. So uh, to service the air conditioning. So from this condition, yeah, as mentioned in the graph, yeah, you can show will be experienced by different of temperature. So by during the transferring, the temperature already changed. Yeah? So you can see from the CC is a lower of temperature from the coil, and then by transfer to the SS, the temperature become increased, and then by to service to room already uh, the temperature become to higher. So mean that is service to the occupant should be in the temperature of RF. So mean that if we feel comfort in 22 degrees Celsius, mean that the RF should be 22 degree of uh, Celsius. So if want to achieve in 22 degree of Celsius for equipment, mean that the CC should be lower than 22. That's how the principle by using the psychometric charge. Yeah. So for the formula, yeah, actually we can sum, yeah, this parameter from the other sources of the can be contribute of the heat, yeah. Let's say uh, from the solar, yeah, heat gain from the solar, from the ventilating, yeah, and from the outside also, and then the space area, yeah. So we try to calculate all that by sum. Then we can call this one is the cooling load. Yeah. Okay. The space cooling load is used to determine the supply volume flow rate, whereas the coil load is used to determine the size of the cooling coil in air handling unit or the X coil in the package unit. Yeah. And the cooling load component influence both the size of the cooling load, cooling coil, whereas the load component may not affected. Yeah. Infiltration heat gain is a instantaneous cooling load from figure is apparent that the load due to the outdoor ventilating or air QO, sometimes called the ventilating load. Is coil if QO considered as cooling load, the volume flow rate of the air system will be oversized. Yeah, so mean that if we give the cooling load is more than we need, mean that we calculate with the oversize. So that how we try to illustrate the condition that can be contribute in the heat. So sometimes the waste, yeah, will be create more heat, yeah, transfer compared to other like east is maybe compare to west is lower, yeah, because it's just morning part, and then the west is noon side. So that's why at noon will be create more of the uh, heat, yeah. So from this condition, we can understand, yeah, where is beginning of the cooling load, where is the constant cooling load, and where is the peak of the cooling load. So from this characteristic, yeah, we try to combination of the cooling load. So mean that we have the sensor to read the space, yeah. Once the space increase of the temperature, the refrigeration, yeah, we can active or more load, yeah, to reject the heat. Okay, that's how to describe the cooling load, yeah, for the this subject. So now you can understand if you relate to the our subject in design project, you can be implement how the cooling load work. Yeah, mean that maybe you need to sensor, or sometime maybe if temperature is constant, mean that you need to take account to measure the temperature is achieved. Yeah, that's all for today. And before that, please make sure you attend the attendant in this week by answering the quiz. That's all for today. Thank you. Assalamualaikum and good day.